phase. What is meant by phase? Phase is time period elapsed from the reference. Here if we see, for example, let us consider the reference as this waveform. This waveform as the reference. Since it is starting from the origin, I am considering this as a reference. Now here there is another waveform which is starting at this point. Let us assume this is 1 and this is 2. Now 2 is started after a delay of pi by 2. After a gap of pi by 2, 2 is started. So we are telling this 2 with reference to 1. Always the phase will be telling with reference to other. When we consider 1 as a reference which is starting from the origin, so this 2 waveform is started after a time period of pi by 2. So this is said to be lagging with an angle of pi by 2. Similarly, when we consider the waveform 3 or B, here I used B is started before a time period of minus pi by 3 with respect to the waveform 1, which is the reference. So it is said to be leading. This leading and lagging concepts usually will be tend with respect to a reference. Reference is very important when we consider this phase. So with respect to this as a reference, so I have mentioned here this is the reference. With respect to that as a reference, this A lags the reference by an angle of pi by 2 and B is leading. This B is leading with an angle of pi by 3. This is regarding the phase. Then average value. Average value usually we will be telling if the value is producing same charge, then we will tell this as an average value. When we come to RMS value, there are a process for finding this average and RMS value which we will see later, but the usual definition will be compensating the same charge for the average value, same heating effect for the RMS value. Then form factor. Form factor Kf is RMS value by average value. Peak factor. Peak factor is maximum value divided by RMS value. Now let us see this calculation of average and RMS value for different things. First I am taking a sinusoidal waveform which is starting from the origin. So the positive max, the positive peak is Vm and the negative peak is minus Vm. Now we have different methods to calculate this average and RMS values. First, there is an important rule. If the waveform is symmetrical waveform, that is symmetrical in the sense symmetrical is with respect to x-axis. If we see the positive half cycle waveform and the negative half cycle waveform are looking alike, that is symmetrical with respect to x-axis. Whenever for symmetric waveforms, it is enough to calculate the average value for only half cycle. So here, since this sinusoidal waveform is symmetrical with respect to x-axis, I am considering only half cycle, that is 0 to pi. There are different methods for calculating this average value. The first method is integration. So when we are finding this average value with this integration method, since the sinusoidal waveform is a symmetrical waveform, it is enough if we consider only half cycle. So if we see here, I am considering from 0 to pi only half cycle, and the value of the waveform, since it is a sinusoidal waveform, as I had already told, the waveform usually will be plotted for the instantaneous value with respect to time. The instantaneous value of a sinusoidal waveform will be Vm sin omega t, since this is a sinusoidal waveform. So 1 by pi integral of 0 to pi Vm sin omega t will give us the average value. Only half cycle consideration for symmetrical waveform is valid only for the symmetrical, only for the average value calculation. This half cycle integration, if it is a symmetrical waveform, rule only valid for average value. For RMS value, we need to take one full cycle. Here one full cycle in the sense 0 to pi. So 1 by 2 pi integral 0 to pi, since it is a RMS, root mean square root of 1 by 2 pi 0 to pi Vm sin omega t whole square d omega t will give us the RMS value. Similarly, if we see some other things here, the first waveform is a periodic waveform. If periodic waveform, it is enough to calculate for one cycle. So it will be it is repeating for every pi. So it is 1 by pi integral 0 to pi Vm sin omega t. That is the period. And the RMS value will be square root of 1 by pi integral 0 to pi Vm sin omega t whole square dt. As for the second waveform, here it is periodic, that is the repeating is 2 pi. 0 to pi we have a sinusoidal waveform, pi to 2 pi there is nothing. So here again the average value will be 1 by 2 pi or else 1 by 2 pi integral 0 to pi Vm sin omega t dt plus 1 by 2 pi integral pi to 2 pi 0 omega t dt. And then the root mean square velocity will be square root of 1 by 2 pi integral 0 to pi Vm sin omega t whole square dt plus integral pi to 2 pi 0 square omega t d omega t. Yeah. And the second method, so far we have seen the method of integration to calculate the average and RMS values. The second method is area, finding the area. See, I am showing here this rule we have already seen. If it is a symmetrical waveform, for finding the average value we can consider only half cycle, but for RMS value we need to calculate the full cycle. So using this area method, I will show for this sinusoid square wave, square curve. As we have already seen, using integration method, what is the thing here? Since this waveform 0 to t by 2 in the positive half cycle, t by 2 to t in the negative half cycle are symmetrical over the x-axis, we can consider only half cycle in the integration method. So using integration method, the average value is 1 by t by 2 integral 0 to t by 2, and from 0 to t by 2 the value is 100. So 100 dt, that is using integration method. Using area method, we need to find the area under the curve. Since it is a rectangle, half into base into height. So 1 by t by 2 into base is t by 2, height is 100. So this gives the average value. And for RMS value, as we have already seen, using integration method, even though it is symmetrical, for RMS we need to consider the full cycle. So square root of 1 by t 0 to t by 2 100 square dt plus t by 2 to t minus 100 square dt. That is for the RMS value calculation. And yeah, for RMS value calculation, using the area method, how to find? What we need to do is, you just need to do the square of the waveform. Previously it is 0 to t by 2 positive half cycle, t by 2 to t negative half cycle. Now if you square, what it will happen? 0 to t by 2 positive half cycle with an amplitude of 100 square, that is 10 power 4, and t by 2 to t negative half cycle, that is minus 100 whole square, it is plus 10 power 4. So the squared waveform will be completely 0 to t with a magnitude of 100 square. So the RMS value is again the area under this squared curve. RMS value for the area using this area method can be done by getting a squared curve. Area for average value, just the area under the normal curve. For RMS value, area under the squared curve. So the squared curve area will be 1 by t, base is t, height is 10 power 4. One important point when we are using this area method is, sometimes we may have a rectangle, triangle. For triangle, if it is a normal thing, half into base into height would be fine. Yeah. Yeah, sorry, we have seen something wrong. Here 0 to t by 2, it is a squared curve, so it is length into breadth. Even though the area is length into breadth, we should consider the 1 by that time period, 1 by t by 2 into length into breadth. Half into base into height is for the triangle. Here it is a rectangle. Rectangle length into breadth is the area, but the average time, average value calculation is area 1 by time period, that is 1 by this x-axis into area. So 1 by t by 2 into length into breadth. Similarly, I will also correct here for the squared curve also. Here the area of the squared curve is only length into breadth, that is t into 10 power 4, but 1 by t we should consider. Then now comes the triangle. Whenever there is a triangle, it is always important that for triangle it is half into base into height, which can be considered for the average value calculation. But when the RMS values comes, how to find the squared curve? So I have given the diagram. For the squared curve, the height becomes h square and the length, this base becomes b only, and the area of this formed squared curve will be 1 by 3 bh square. Just remember this, when this triangle squared curve will be 1 by 3 bh square is the area of the squared curve of a triangle. Now let us see a typical one. Here 0 to pi by 3, it is a triangle. So usually what will be the average value? 1 by pi by 3 into half into base into height, and for this pi by 3 to 2 pi by 3, what is the, it is a rectangle, so area will be LB. So for this part it will be this duration, 2 pi by 3 minus pi by 3 is pi by 3. So again 1 by pi by 3 into L into B. Again 2 pi by 3 to pi, what is that? It is a rectangle, it is a triangle. So again half into base into height. So what is the difference? Pi by 3 minus 2 pi by 3 is pi by 3. So 1 by pi by 3 into half into base into height. So the total average value of this first waveform will be 1 by pi by 3 into half into base is pi by 3, height is Vm, plus 1 by 2 pi by 3 minus pi by 3, that is 1 by pi by 3 into length into breadth, that is height, that is this one thing is Vm, other thing is 2 pi by 3 minus pi by 3, which is pi by 3, plus 1 by this base, 1 by this base is pi minus 2 pi by 3, which is again pi by 3. So 1 by pi by 3 into half into base into height. Again base is pi minus 2 pi by 3 pi by 3, height is Vm. That is the average value. And for RMS value, we need to make the squared curve. So for 0 to pi by 3, I just before showed the squared curve of a triangle. It will be like this, and for pi by 3 to 2 pi by 3, the squared curve will be Vm square, and for 2 pi by 3 to pi, again it is a triangle, the squared curve is like this. So now what will be the RMS value? 0 to pi, so 1 by pi by 3 into 1 by 3 bh square. So 1 by pi by 3 into 1 by 3 into pi by 3 into h square. What is the height here? H square is Vm square, plus 1 by this difference, 2 pi by 3 minus pi by 3 is pi by 3, 1 by pi by 3 into base into height, length into breadth. So Vm square into 2 pi by 3 minus pi by 3, plus 1 by pi minus 2 pi by 3, again pi by 3, 1 by pi by 3 into area again is 1 by 3 bh square. H square in the sense this height square here, not the, see in the squared curve we can tell this as 1 by 3 bh. Here you can see, right, this thing 1 by 3 into b into h. Here what I mean actually is this complete thing is h square, so I just wrote h square. Doesn't mean this value should be squared again, that is not h power 4. Just note that you can consider 1 by 3 bh or else, where b and h are the values of the squared curve. Yeah, then this is the area method. Equation method might be complex, so for now it is not needed. Yeah, so far this can be for the average and RMS values. Thank you. We will see the next part, that is RLC, RL, RC, RLC analysis, AC analysis, and yeah, we will see what is the resonance, everything we will see in the next thing. Yeah, thank you.